All right, folks, so today we're going to learn to go between binary, octal, and hexadecimal. These three forms of writing numbers are actually related. And so you might be thinking doing this might be easy to go back to our decimal form, but actually you can go directly from binary to octal or binary to hexadecimal directly. You don't have to go through base 10. And to do that, you're going to have to make yourself a codex first, which is just a little translation. We want to go from binary to octal. And so what I'm going to do is I need to find out in octal, the biggest number, biggest numeral we use is a 7. So how do I write 7 in binary? Well, 7 in binary is going to be one group of 4, one group of 2, and 1. And so right there is 7 in binary. It's 1. And so that means 6 in binary is going to be 110. And what I want to do is I want to write all of my numbers in binary for 0 through 7. And so 4 is 1, 0, 0. 3 is 0, 1, 1. 2 is 0, 1, 0. 1 is 0, 0, 1. And 0 is 0, 0, 0. Okay, now I wanted to use all three spaces because it took me 3 spaces, place values, to write a 7. And so I wanted each one of these numbers to have 3 place values in the binary sense. And so this is base 8 or octal. And this is binary. Okay, and I can do the same type of codex for hexadecimal as well. And so for hexadecimal, I need to find out what is my number of digits or number of place values needed in binary to make 15, because remember 15 is the biggest number we use in hexadecimal. And so to do that, in hexadecimal, remember that 15 is represented by F. That's 15. And so in binary, that is going to be one group of 8, one group of 4, one group of 2, and then one single. That adds up to 15. And so now that I know that, I want to write all of my numerals in hexadecimal as binary with 4 place values. So that means 0 is going to be 4 zeros. Okay, so give me a moment and I will fill that in. Okay, so I've got our codex made here, and all I'm doing again is writing the digit from hexadecimal, so 0 through 15, excuse me, and I'm writing that as a 4-bit number in binary. All right, so now why am I wanting to do this? Well, for example, what if I want to write the number 10101000101. That is in binary. What if I want to write that in octal? Well, the way you might be thinking is to change that into decimal, a number that we know, and then change that number into octal. And you could do it that way, but there is a shorter way. Again, binary, octal, and hexadecimal are related. And so what we need to do, since octal to binary is a 3-bit transition, see, looking right over here, you see that it takes 3 bits in binary to write a number in octal. And so what we do is we come over here and say, all right, group this into 3 bits. And so I got 3, 3, 3 there. At the last, I've only got 1, so I'm just going to add zeros at the end. That makes it a group of 3. And all I need to do is then write my numbers from my codex that match up. And so, starting over here on the right side, 101, that's 5. 100, that's 4. 0, 1, 0. 0, 1, 0 is 2. And 0, 0, 1 is 1. And so that means this number is 1, 2, 4, 5 in octal. Now, the neat thing here is if I want to write that same number in hexadecimal, so starting out 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, that is in binary. To change it to hexadecimal, all I need to do is make it in groups of 4 rather than 3. And so group of 4, and again, I need 2 zeros there to make a group of 4. And so that same number written in hexadecimal is going to be 5, and then 1, 0, 1, 0 is A, 0, 0, 1, 0 is 2. And so that's 2A5 in hexadecimal. Okay? And so now, you having that same codex, that same chart that tells you the transition there, you can switch from hexadecimal to octal as long as you go through binary. It's a really quick transition to go through binary from hexadecimal to octal, or going from octal to hexadecimal, same thing. You need to go through binary. So rather than going to base 10, just go through binary, and it makes it really, really quick as long as you make yourself a codex first. All right, so for example, I have this number C5A9 written in hexadecimal. I would like to write that in octal. And so to do that, I'm going to go through binary. So I'm going to go ahead and translate it. Looking at my codex here, C, which is 12, is 1100. 5 is 0101. A, which is 10, is 1010, and then 9 is 1001. So that I have now written in binary. I want to change the binary into octal. And so I have to look at that other codex there, and I'm going to group these in groups of 3. And so switching this to a group of 3. Okay, and again, I got that 1 digit at the end, so I'm going to make it a group of 3 by just adding some zeros. Okay, and so now, doesn't matter if you start from left or right, I suppose, on this one. I'm going to start from the left side here. So 001, that is 1. 100 is 4. 010 is 2. 110 is 6. 101 is 5. And 001 is 1. So that is now that same number, but written in octal. All right, so I hope this little translation was clear. Your assignment for me today is on page 214. I would like you to do 65 through 76. And those are just doing the translations between binary, octal, and hexadecimal.